Okay, for last, this tutorial I want to give you some tips about the database layer. So the database layer is the most important thing of all the layers. So before we were checking the networking, the hardware layer, we check about distribution systems, we check about the application layer, backend, front ends, and then we had the database. So this is what this tutorial is about, database layer. So you need to decide if you want to have SQL or non-SQL database, and then if you decide to have SQL database, you need to decide if you want to have relational or non-relational diagrams. Let's call these as with foreign keys. You can still have a logical relational database without foreign keys, but this is just basically to explain to you. Let's call it relational where you have foreign keys. Let's call it non-relational when you don't have foreign keys. Okay, I call it here diagrams. Let's put it here tables, whatever. So basically you need to make this decision. So and then you need to decide which database you want to use. So I can tell you that MySQL, even with foreign keys, it works very fast. So it's always better you choose the relational database with foreign keys, because in case it's much more secure. In case you delete something that you should not delete, if it contains some dependencies, if the table is configured correctly, it will not allow that. If you have too many dependencies and if you want to delete something, and if you are really allowed to delete that, it can automatically delete in a cascade mode. Automatically it can delete all the dependencies also. So there are a bunch of functions that it could be very useful when you have relational databases with foreign keys. So I strongly advise to have foreign keys, independence if it is MySQL or other type of databases. Or if you don't want to have a non-SQL, you can always use MongoDB, but this is a completely different structure because it's a documental structure. Imagine this as a JSON type of structure where everything is saved by documents. Let's say you have the user. Inside of the user, if the user contains permissions, then you have the list of permissions for each user. So you have basically you are replicating a lot of information in this type, but it is when you fetch the data, it is much faster than fetching from relational database. So there are some it makes sense for some cases, it doesn't make sense for some other cases. It depends of your database structure, what you really want to have. So for me, I'm more used to create systems based in relational database, so my preference is always relational databases. I always try to avoid documental structures, but that's only my preference. Although I always recognize the advantage of having MongoDB, obviously. Okay, so after you have all these decisions taken, then you need to organize your database tables structure. So let's call it the tables diagram. And in here, what you should do, you should organize or group your tables per prefix. So otherwise, like everything, all the tables that are related with the user, maybe it should start with MU, module user, something like that. You have in here all the users. You're gonna have the permissions. You're gonna have the user permissions. You may have the user authentications, user sessions, whatever. You may have the user the activities for the specific that then combines with the specific permissions. Then you may have the user activities, activity table that says that basically this user can execute this specific activity based in this permission or whatever, or this is very similar also, but this is just an example. But all of these tables basically you'll have the prefix mu, so basically something like this. So when you are executing, when you look to your database, you can understand what belongs to what. So if you have multiple modules in the same database, you can understand right away the differences. Or you can, as I explained before in the previous tutorial, when I was explaining in the application layer, if you decide to have independent projects, they can share the same database, or they can share different databases, which you can always do. That's your choice. It depends of the requirements, depends of a bunch of things. Yeah, so basically that's it. Then for performance, you need to think about creating views. If there is something that is very high performance and you think that you can do it inside of the database, you can think about store procedures, but still, like, store procedure is like logic code, so maybe this logic code, it should be in the application layer. Although you can do some logic code much faster in store procedures inside of the database, so try to avoid these, in my opinion, or just use these in specific cases. But still, these store procedures, the names of the store procedures, also if it should be organized by groups, by contacts, the same thing than these tables here, by modules. So you need always to organize your table with that. So I can tell you that I already work in projects where you have more than 1000 tables, and when you want to understand what you have there, it is a pain in the ass. Then you can configure, then you can think about partition like tables. If you have like huge, let's say that you have a user activity log table, contains all the user activity logs. Maybe you want to partition this table by user, where you can have multiple different tables, so you can configure the database to do this automatically, or you can have this yourself based in the specific user ID. You in the logic code, in the application layer, you can decide, oh, if the user ID is the ID is between 1 to 1 million, goes to the user log 1, otherwise goes to the user log 2. If it is bigger than 3 millions, go to the user log 4, whatever. Like you can do this in automatically way in the application layer way. Also, then you can configure this. When you configure this automatically, you are creating clusters, which is sharding, which makes the database much faster. Also, databases, if it is relational or non-relational databases, you should always have master and slave. If you need to have two masters, it gets much more complicated, but my advice is one master for writes, multiple slaves for reads. That's independent if you have relational database, if you have non-relational SQL databases, non-SQL databases, you should always use master and slaves. Yeah, and basically that's it. So from the top of my mind, I'm sure that there are much more things related with this. If I start thinking more about this, I'm sure that I will remember more things, but from the top of my mind, this is what I remember currently. I just remember another thing where you have, when you're creating the tables, you have multiple type of tables that you can create. You have different engines that you can assign. So like in MySQL you have innodb, myxam, you have different ones. You can create tables in memory. You have different types of tables that you can create, and automatically the performance in each of these engines, it will be different also. So each type of databases have their own features, their own engines that you can always choose when you're creating the tables. You can choose which type of tables you can have. Also, I'm not sure if I talk about views. Also, let's say that you have like a request. I did. Okay, creating views. Okay, it's here. Yeah, so basically that's it. So just keep in mind that tables you can have a simple creating table in the database, but you can always have memory tables to fetch the data much faster. So yeah, basically that's it.